Hi, I'm Professor Damon Sisk. If you already know me, feel free to skip this video since it's just an introduction. I graduated in 2000 with a bachelor's degree in chemical engineering and then in 2002 with a master's degree in mechanical engineering, both from Purdue University. My master's area of specialization was robotics and automation. During my master's degree work, I analyzed a novel Mars rover robot concept called Axle for Jet Propulsion Laboratory, or JPL, and it was basically a can between two wheels. I recommended adding a tail to the back of the central cylindrical body to provide a longer moment arm and therefore higher torque capacity to the robot's wheels. Today, any of the materials you see related to the axle actually includes that tail. After graduation, I worked for a company, Amatrol Incorporated, in Jeffersonville, Indiana. They make technical products for education. They consider their primary product to be curriculum, but they also make hardware to support the curriculum. I was a mechanical design engineer and updated or created product designs. One product I designed was a vibration trainer. The product was created to train people on performing predictive maintenance on equipment. Failure of critical equipment can cost quite a lot in production while the equipment is offline. The concept behind vibratory predictive maintenance is to monitor the equipment and flag changes in its vibration signature, then perform maintenance before the equipment fails. This technique is particularly well suited for moving equipment, motors, bearings, etc. The T5554 or chemical process trainer is another product that I designed. It's a chemical process trainer to control pH. It simulates feedback control of wastewater acidity before the wastewater is disposed. The Saturn robot was supposed to be one of Amatrol's top-of-the-line robots, but was not very strong and experienced frequent failures, and as a result, it frustrated customers in the field who owned one. I redesigned 3 of the axes and made it cheaper to build and much more powerful. Amatrol has apparently discontinued the robot, but I think it is because Fanuc and several other manufacturers have introduced robots in the same size and performance range that are mass-produced, and so they have all the advantages and refinement that process offers. So it is probably no longer economical to make a few Saturn robots per year when they can simply buy a better robot for less. Another product I designed was the Mechatronics Trainer. I designed the sheet metal and the rest of the base carts, as well as the upper surface works on the last few stations. The entire system was an assembly line for some small pneumatic valves which could be made in several combinations of options. Each of the carts provided a different function along the line to assemble the valves. A common problem with educational hardware is how a school affords enough of it to supply each student in the class. The idea behind this mechatronic trainer was that each cart could accommodate 2 students, which yields a capacity for 14 students in one class. When I left Amatrol in 2007, the trainer cost over $100,000. They're still being sold today and so apparently are profitable for Amatrol. That suggests to me that it was a good design. From current photos, it appears they have not changed my design much, so I'm proud of the fact that I apparently did a good job. After Amatrol, I went to Grote Industries of Madison, Indiana. Their main product is exterior lighting for original equipment manufacturers in the heavy truck industry. You may recognize their marker lamps from seeing semi-trailers on the highway. They moved from incandescent light bulbs to light-emitting diode technology and saw the reliability and longevity of their product revolutionized. Then they came across a novel LED encapsulation process that they thought might revolutionize their products again. They hired me to design equipment for researching and manufacturing the novel LED light engine. I designed a custom precision laminator as well as many other machines. It used programmable stepper motors and aided in the research efforts. See, the original company did not have very high yields, so a lot of the time the product they made would simply not light and was garbage. We figured out why it did not work so frequently and made big improvements in the process to increase the percentage of product that worked as it came off the line. The laminator was one particular time I had to break out my textbooks, build a spreadsheet, and use transient heat transfer equations to model heat loss. That allowed me to determine the power requirements for a preheating tunnel on the laminator. You can see the difference between a typical LED light strip here and the ones produced by Grote. Grote's light form is thinner, more flexible, and reliable. While at Grote, I was approached by faculty at Purdue Polytechnic New Albany and invited to come teach full-time. I had taught for the location occasionally as an adjunct and really enjoyed seeing students develop. I love engineering and I want you to as well. I transitioned from Grote to Purdue in 2007. Since then, I have taught 14 different courses. Most have been in mechanical engineering technology, but several border on electrical and computer engineering technology subjects. But the best part by far is seeing students learn and become excited about engineering.